Now, the human rhinovirus, um, common cold, and there's more than 110 serotypes here. It's got such a unique molecular surface that is doubtful there will ever be a vaccine. And there are many different strains that circulate in the population at one time. You get it from contaminated hands and fomites. So what does that tell us? Wash your hands often. It's very sensitive to acidic environments. It can't survive above 33 degrees Celsius. You can have headache, chills, fatigue, sore throat, cough, and nasal drainage, and all you can do is treat the symptoms. Antibiotics do not help because it is a virus. The non-enveloped segmented double-stranded RNA viruses are called reoviruses, and it's unusual because the RNA strand is double-stranded. The reovirus causes a cold-like upper respiratory infection, and the rotavirus, which is often a cause of mortality and morbidity in infants and children, is because of all the diarrhea it causes from oral fecal transmission. Now, prions and spongiform encephalopathies. We talked a bit about these earlier in the semester. Prions are proteinaceous infectious particles where the protein is misfolded, and they are resistant to chemicals, radiation, and heat. So they cause this transmissible spongiform encephalopathies. In humans, we call it Crutchfield-Jakob disease, and in animals, it's called mad cow disease. The properties of these spongiform encephalopathies, they consist entirely of protein. There's no nucleic acid. As we said, they are resistant to chemicals, heat, and radiation, so you can autoclave them and it does not get rid of them. They don't have the typical virus morphology. Since there's no nucleic acid, they're not integrated into nucleic acid of infected host cells. They don't cause inflammatory reaction or cytopathic effects. They don't cause antibody formation in the host. It causes vacuoles and abnormal fibers to form in the brain of the host, and it's transmitted by close, direct contact with these infected tissues and secretions. So if you work with patients that have this, it's going to be suiting up, mask, gloves, everything, everything. You're going to have to be extremely, extremely careful. Crutchfield-Jakob disease, it converts the normal protein that's in the human brain to the abnormal. And then the abnormals cause more conversion, and it causes nerve cell death and spongiform damage, and loss of brain function is severe. And again, you've got to have direct contact with infected tissues for it to be transmitted. A variant of Crutchfield-Jakob appeared in the late 1990s because people ate meat from cattle that were afflicted with this bovine spongiform encephalopathy. The brain has to be a biopsy to diagnose it. There's no treatment. You just try to ease the symptoms, and patients are going to die. This happened in Great Britain, and people that were traveling in Great Britain at that time are never allowed to give blood. Never allowed to give blood. Which of the following enzymes would degrade the causative agent of Crutchfield-Jakob disease? And the answer here is D. Neither will affect it. None of the